Thank you everybody for being here. I think we heard some interesting speeches, especially this morning the opening speech of Kai was, I think, a very nice view, a glimpse into the very far future. I'm trying to concentrate a bit more on the near future and what are the next implications that are coming up for us. So I'm going to start with a short introduction of what we're doing actually, and then go a bit more into depths on the treatment of the topic of Industry 4.0 in different nations and different companies, how is it actually implemented, and then give you some practical results. So yeah, basically Fraunhofer, I think most of you will have heard of it. We have 80 research institutes, 24,000 employees, annual budget of 2.1 billion euros for research. We're registering every day in average 2 patents. And what most people don't know, that we, for example, invented MP3 about 15, nearly 20 years ago. And before, for example, the airbags together with Bosch and Mercedes. So this is a very typical working principle that we have to work together with the industry on realistic projects that we really transfer into the industry. So this comes from where basically Joseph from Fraunhofer had 3 different attitudes that he combined. He was a researcher on the one hand. He discovered the Fraunhofer lines in the solar spectrum. You can see there's down there the solar spectrum. There's a couple of black lines, and this is light, which is spectrum of light which is not transmitted by the sun. Then he developed new processing methods for lenses, so very practical inventor, and he also implemented all this in his glassworks company, so he was an entrepreneur. This is why, for example, at Fraunhofer we also have Fraunhofer Venture, where we bring our ideas into new companies. We are based in Berlin. Together with the side of the Technical University, we have about 600 employees. Also another typical Fraunhofer example is that we work together with university. On the one side you see the Technical University of Berlin in our building, on the other side IPK, and this is how we transfer knowledge from basic research into application. In IPK itself, we're trying to cover the whole value chain of a company, from the management over product creation. We've heard a couple of examples. Nowadays it's all virtual, and then bringing this into the production, having the production technologies, automation for sure for this, and quality management. So we are really trying to cover with integrated projects also the whole range of products, and this is actually our department structure, which is oriented towards the service delivery to our customers. I myself, I'm from the Competence Center of Innovation Systems and Structures. What we are doing is we are planning globally different entities for innovation. We are working on different levels. For example, we work for governments where we analyze the whole innovation system, how universities work together with industry, which research programs to set up. We also develop science parks. We've been doing that, for example, in Sharjah and in Dubai, and we also go really down to hands-on implementation. I will talk a bit more about our Sino-German Intelligent Manufacturing Research Institute later on, where we really deliver also the technology. We go together to the clients and really bring it into on the ground basically. So we're really trying to cover the whole range from analysis down to practical implementation. So saying this, and I think you've probably talked to some people from SPI or from other organizers which are also organizing this event here. We are currently engaged in the project of the European Union in the establishment of the European Network of Research and Innovation Centers and Hubs in China. We will support European companies, also with some sort of soft landing schemes, different services. We are still working on the establishment of the focus that we are going to set, and I think I've heard some really interesting approaches here and where we can work together. So please come back to us. You can see the online address. Also, we just had our launch event 2 weeks ago. The first center will be attached in Beijing to the EU SME Center, and the second one is a regional hub in Chengdu. We are planning to open 15 regional hubs, and we are looking for European and Chinese partners to deliver a service. So this is really a publicly funded project with the objective to support collaboration in terms of research and innovation between Europe and China. So this is really a project where we're looking for partners, and everybody is invited to go together with us. You can see also the email address down here for direct contact. So just to let you know, this is under a common brand name. This is the second project, Enrich in Brazil, with a very similar structure, and the third one, which SPI is involved in, for example, and EBN, other partners, is in the USA. We are not part of that project, but if you have activities in Brazil or the US, you're also welcome to contact us or SPI and work together in Brazil or the US. Okay, then let's go to the actual topic that I want to talk about. I'm moving a bit away and looking at a more general perspective on Industry 4.0. So just a short clarification, where does the term come from? So the first industrial revolution was mechanization, water and steam power. Industrial revolution, the second one was terrorism, mass production. Then we had the third industrial revolution with automation, and the fourth one with the connected devices and intelligence. I think what's really important for us always to say at this point is many people only think in technologies, and for us the technology is the easy part or the easier part on this. What's really different is the whole system and the management behind it that's complicated. How to integrate the people, how to organize it, how to bring it into certain compatibility modes that the different systems can work together. It's a much more complex system, especially when we're talking to a Chinese customer. It's a lot about specific technologies, and I think this is a rather simple part of this whole thing. So for us, it's really to see Industry 4.0 as a whole production principle, which demands completely different approaches. The Americans, for example, call it the industrial internet, and this is really, for me, the most boring term of all, because this is just another cable that you lie somewhere, and it totally doesn't reflect what the revolution that we are seeing right now is all about. So, what are we hoping for? What will this enable us? What we see here is the loop, where we on the one hand see the product variance and the volume per variant. So in the beginning we're looking at the example of the car manufacturer. There was maybe every car manufacturer producing 3 cars in a year. So it was really very high number of variants that were available, and this was reduced when Henry Ford came in. The market was quite quickly consolidated to a few big players, and when he introduced the mass production, he said people can have the Model T in any color as long as it's black. So this was the moment where we had very high efficiency in the production due to limitation on the variants. And now we're going more and more back into customized cars by theory. Any car that is produced from the capability, from the number of variants, would not be produced twice, for sure. There's a company that orders the cheapest model in white 100,000 times, and in practice there is. But nowadays we have so many variants that we could use our production facilities and not ever produce the exactly same car again. And this trend will continue. So this whole change is based on different sets of technology, and what we've seen in the last years is always a first super big hype on one specific technology. So when we talk about augmented reality, for example, in the beginning, everybody was maybe 5 years ago, oh, this is the future, this is the future. Everybody is super smart and talking about it, and nobody actually brought it into really the applications that we are hoping for. So this is what we call the sort of disillusionment, where we usually have very high expectations, and then after some time we figure, oh, this was not so easy as we thought, and maybe it's too expensive or too complicated, or when we look at all these virtual reality and the glasses, people get sick, manufacturers we maybe didn't think of. So yeah, part of research is always also the trying and also the dying. And yeah, for sure there's always technologies which survive, which are getting big. For example, 3D printing is maybe a topic we've been working on for 15 years, 20 years, and now we are actually in the mode where we say, okay, the applications are there, Adidas is producing shoes on demand, the airplane industry is really picking up and using it, we're using it maybe for buildings, but it took 15 years, and the idea has been there all the time. And this is with many topics. We see in the video with the smart robots, and we'll actually see they are right now in the very beginning. This is what we see here on the stage, and we'll see if we have maybe a completely different talk in 5 years. But this is always something that you have to consider, and that not all the technologies will survive. So, even more funny is everybody's talking about the super modern, most crazy things he can think of, and then you actually go into the factory and you do a consulting project. And what do you see? Most people have maybe, if they are okay, they have reached a good level of the first digitalization. Maybe they have a good, well-working ERP system and automated data processing, and we are already very happy. The second level, large data analysis, cloud computing, internal social media, whatsoever, then you are already in shallow waters, and very few companies will work with it. On the third level of digitalization, self-adapting processes, completely digitally oriented business models. There's not even a company in the world that has reached that. So we always keep this vision of intelligent manufacturing in mind, but we also have to be aware that most of the companies have not even reached the first basic level of automation. And this is really interesting because everybody is doing big talks and in the end not even able to have his data in a quality that you can do just an Excel analysis. So yeah, the gap is quite big between what people are talking and what they are doing. Anyways, the trend is there, the things will come, and the companies who are good at it, they will survive, and the ones who are not, they will be replaced by other companies. So also many governments have seen this and also the need for support for the companies, but the approaches are quite different that different countries are actually using. For example, China is more going into the direction of speed, very quick implementation of very practical, small-scale solutions. In Germany, we are looking into the perspective of engineering excellence. We want to transform our very strong global leaders, small and medium-sized enterprises in niches. We want to transform them and bring them into the next age and ensure their survival. So the USA is standing for radical innovation, supporting massively startups, huge venture capital scene, allowing a completely different treatment of the topic of Industry 4.0 than we have in Germany, where this big scene of venture capital is actually just missing, and the money and experience how to promote companies and bring them to the super big level is not there. Japan and South Korea, again, a completely different model. They have huge mass manufacturers, they have Samsung, they have Sony, and they are really working on a, I would say, a rather easy case, more practical, and using their mass production and bringing it into the smart age. This is what you can see also when you look at Foxconn, for example. For them it will be quite easy to completely automate their companies because factories, because they're working with less variety in product. But this is actually, I think, happening already, and the next generation of iPhones will be produced with maybe half of the people that they are using right now, because they're going really strongly, also due to the increasing labor costs, into higher automation, which doesn't necessarily mean Industry 4.0. It doesn't have to be smart yet, but still the trend is there, and I think the first learnings that can be taken from there. Yeah, there's huge fundings all over the globe from different governments to support different approaches. I'm not going into detail. If you're really interested in numbers and in the names of the programs, you can just drop me a line, and I can give you the presentation. You can maybe dig a bit further. But you know the Made in China initiatives, you know the Industry 4.0 initiatives as European programs. So all the different countries are setting up standardization groups, fundings for SMEs. The Italians have a very big, actually it's a credit-based program, but it's very huge to update factories of 13 billion euros. So initiatives are quite diverse, and still always with a considerable amount of money equipped. So I want to go back and see not the vision, but the practical implications that we're having. So in Germany, 70% of medium-sized companies see actually that there is a challenge in digital transformation, and 55% do not have a centralized digitization strategy. So the topic is aware, but people just don't know what to do with it. Especially because there's also maybe people who are just overwhelmed in this very quick change, who are not maybe even yet used to their iPhone and still struggling, and they have to set up a digitization strategy. So I think there's really a crucial importance for anybody who can support here with experience in these companies. Also, when you look into a classification of the different companies that we are having, there's a certain set of criteria to classify them: digital resistor, digital explorer, digital player, digital transformer, and digital disruptor. So in Germany in 2015, there's 6% of the companies digital disruptors, 12% digital transformers, and we can see this is 18%. That is not even a fifth of the German companies that are somehow taking a lead in the global change in digitization. And this is really something that we have to think about it. Everybody's talking about it, and nobody knows how to deal with these changes that are coming up. So the question is, who is actually driving the change? So there's a small and medium-sized enterprise, and usually whatever you do, they will be overwhelmed with what is happening. There might be a few new players, but who will actually drive the change is the people and the companies and the products who are already in the factories. They're the ones who have implemented it, and they know how it's working and what to change. So the automation vendors, what we can see here: Siemens, ABB, Amazon, then there's Schneider Electric and Rockwell, well-known names. And those are the ones who will actually drive the change. And we can also see this is mostly still Western companies that really do this automation, and they will be still in the highest responsibility to drive this change. We also need the respective tools, and also the tools itself and the machines, they will change. And there we can already see that China is coming in with big steps. They are even global leaders in the production value of machine tools. Then we have Japan, Germany, and South Korea already with some distance. So these will be actually the nations that will drive this change as well, more on the machine side. So who is this going to be? Well-known names also. Trump with the especially laser business, also doing a lot of efforts in 3D printing. And then the second one already is a Shenyang group from China, which you wouldn't even maybe expect if you're not an expert in the area. But also we can see here, then there's Amada from Japan, and then the fourth one is again DMTG from China. So what we can really see here is from the factories and from the companies that will drive the change, it's going to be the Germans, the Chinese, the Japanese, and then maybe at some point the Americans also, and further nations are following, then maybe Italians also with some sort of expertise in the area. Industrial robots, also for me it was in the beginning quite surprising. In Germany everybody's talking about KUKA since they were overtaken especially by Medea, but the world's biggest manufacturer is actually Mitsubishi, you know. And Mitsubishi for sure also has a big advantage in having implemented all different kinds of industries in itself. Being a car manufacturer, being nowadays also airplane manufacturer, and I'm not even sure, I think they produce all kind of household things as well. And we have ABB Robotics for sure, and then already the distance quite big to Fanuc. So even though we see here still the established companies up there, the Chinese are catching up. The Chinese robotics market is huge. Also, the Chinese take a big share in the global production, just that there is not the one big player. The market is still consolidating, but for sure, if you know the robotics markets in China, you know a lot of things are happening there, and the change is also coming from there. I'm expecting some sort of consolidation in the next years, yeah. So, most funny thing is who's going to be driving the change in Industry 4.0. Still, most of the people think it's the Americans. Probably you answered this questionnaire as well. Maybe you're going to answer it differently after this presentation. So for sure, we shouldn't underestimate the Americans, but we should also be aware that there's, for sure, China anyways, strongly leading this change. Germany, the Japanese, for sure, also. So, what does it mean? There's millions of approaches on how to implement it. I'm just going to give you some examples on what Industry 4.0 can mean in practice, because it's such a diverse field that, that there's not one unique definition out of it. And you can start in a very small scale, you can set up a whole new factory, you can set up a whole new supply chain, so there's endless possibilities. Just to give you some examples, and all the big companies are for sure working on this. Audi, for example, working on electronic build sheets that you can even more customize your cars with the sheets itself. Then you have Volkswagen with different internal initiatives to improve production. For sure, this is just like some examples that we are looking for. There's much more going on that we probably don't even know about. BMW had a very nice example where they had the augmented reality for training their employees in maintenance of their cars, where they would be shown what to do. For sure, leading industry is also aeronautic industry. 3D printing process is now being established. Embraer is switching to a paperless organization. Virtual trainings for sure also picking up. We've heard about before the 3D drawings, real-time adjustments, a whole production set up virtually to not have to go in the physical prototyping process. We have the two big competitors, Siemens and GE. Both are actually now setting up their own app stores. The first one to lead this initiative was GE, setting up the Predix, which is basically your app store for industrial applications. Siemens is now also following, and for sure also different showcase factories that are being equipped, maybe even at own cost or with losses, but just to show the possibilities. And there's many demonstrators here in China. We've visited a couple of, especially also from the Chinese government funded demonstrators in factories, but to be frank, that anybody would have implemented the real meaning of Industry 4.0, that hasn't happened yet. So there's still a lot of things to do, even though the initiatives are there. A real factory that is all adjustable, that has all the real-time data transparency, we haven't seen that so far anywhere. Yeah, some more things also involve more involvement of entrepreneurs. I think this is another trend, more organizational. All the companies also now starting with SMEs in Germany are setting up innovating hubs or whatever they call it in the startup capitals in Germany. Would be usually Berlin, maybe Munich with a more technology focus, and to get into touch with the people who really have the cutting edge technologies and to understand how to bring them into application. The last example I'm going to give is just because I thought it was very interesting, because you might think somebody like Schindler, who's producing elevators, what is he going to do with Industry 4.0? Maybe only in the production, but whatsoever, there's a lot of intelligence, predictive maintenance in all of the pumps, in all of the electric motors that he's using, so that Schindler, for example, will know that the elevator will break down in 10 hours already, and they can already send out their maintenance crews. And for example, this offers a lot of potential for new business models, because everybody will want to have the original Schindler service that has access to this data to not be trapped in the elevator, because the people who decide on if they're going to buy it or not, or from whom, are probably the same ones who use the elevator, and they also don't want to be trapped. So a lot of new business models, especially concerning maintenance, that are coming up. Pirelli also having set up a really interesting process with the modular robot systems, which is much more flexible than the production system they had before. So I'm just going to give some more examples on what we are actually doing. So generally, when we look into a factory, we distinguish three levels: smart objects, smart factory, and smart enterprise. And when we look at it, there's different sets of solutions that we are offering. When we look at the objects level, we're talking about smart logistics, autonomous transporting, smart machines, cyber-physical system. Then we have intelligence tools, where we have tracking and tracing technologies, mobile assistance for the people working on the shop floor, and e-maintenance, condition monitoring, live. This is really things that are already in use. It's more island solutions, where you're really working on a very specific solution, on a specific topic, not yet integrated, and the most easy level to implement as you just change one part in your factory. So this is already being implemented. But when we look a bit further concerning the factory, plug and work systems, where you really just come in, you go and set up the machine, and it adapts itself. Adaptive control processes that measure themselves and adjust themselves while in production. The smart factory self-organization, reduction of cost concerning the planning, and also factory cloud, the first level of cloud storage on gathering the data of the whole production. Really, when we're looking into the future, is this enterprise level, where we talk about complete digital supply chain, the completely integrated engineering down to the production, completely digitalized business models, the cloud that really stores all the data across all the different channels, and then also concerning the product lifecycle, feedback from the products that are out in the market already, that you can analyze them and know what's going on, and you're not reliant on the actual feedback of the user, but get it yourself. So we've been engaged in this topic for about 15 to 20 years, and it wasn't called Industry 4.0 at that time. So we started very early with scenario projects, then we built up solutions, and nowadays we are into mitigation stage, where we can transfer first results Just to give you some examples, Picasso is a cloud-based control for robots, for example, where you don't need a single computing unit for every robot, but you have the every computational resources in the cloud, a lot of savings concerning hardware, therefore you need real-time Ethernet, really fast Ethernet. I'm going to talk about the self-organized production and Vepro a bit later on in Metamorphosis. RetroNet is equipping old equipment with sensors, and then we have in the migration stage, for example, Jump 4.0, where we go down to the shop floor and integrate Industry 4.0 with mobile devices, with the employees. Just some examples. Self-organized production, what we see here is an agent-based system. Small microcontrollers down there in the corner, you can see the evolution over time. So what happens is that each machine and every workpiece is being attached to this microcontroller. They will know the production steps and they will negotiate with each other which machine is going to do the next task on which kind of workpiece. What's really interesting is that you can go down maybe by simulation our results 20% on the actual production cost by higher utilization. But you can reduce your planning costs by 80%. And when we all think about this, we are always very focused on the production cost and efficiency, and we are always forgetting all the side aspects of where we have further cost savings than the ones which are really obvious and easy to see. So based on this project, we went into a car manufacturer, into Opel, and we implemented it. What we see here is a classical production line, gear manufacturing, 3 lines, 3 different products. And the first thing is we dissolved the complete line system. You can see now the machines are independent from each other, and each of the parts can take a different way after production. And what we did then, we equipped each workpiece and each at least of the containers with an agent-based system that you saw in the pictures before, and they can now talk to each other and negotiate which item is going actually where. To bring it into practical solution, we combined this with a top-down production planning. So we are combining the current principles with the modern principles because it was for a first implementation just not possible to switch completely to agent-based system, but this is a proof of concept that this is actually working and that we can achieve results concerning savings of cost and money. So my last example here is another project we are having with Siemens, Infineon and Festo. We call it the Metamorphosis of the factory. You see the ugly old factory over there, and you see the beautiful butterfly factory of the future. So what are we actually doing? So we're going into the factory very hands-on, and we're doing an analysis, first of all, on the level of transformation concerning digitization. First level is a digital transparency. Do you even understand how your company is working? The second level is digital operational transparency. This means a real-time view on the current operations. This is basically a level probably none of the companies in the world has achieved completely. So this is really a model that we can use probably for the next 10 years or so, maybe 20. So then the digital individual operations, unique requests can be handled like a standard one under the same economic condition. And in the end, the currently highest level, but maybe in 20 years we will extend the scale, integrated operations. This means that the impact of relevant entity changes can be realized to all other entities in the ecosystem. This is self-adapting processes, the self-improving factory that is learning and improving its own processes. This is already a bit what we saw this morning in the video. And yeah, maybe we don't even want that after the video. So, again, I want to come back to my very first word. When I'm here and talking to the people, especially in China, everybody's talking about technology, technology, technology. Technology is the core of the whole thing. But for implementation, you need much more. What we can see here is that technology or technical flexibility in this term is only one dimension we're taking into account. We're talking also about the business model, a very process-oriented structure of the factory. We're talking about organization and human behavior, integration of humans, and we are also talking about the business partner involvement, supply chains, whatsoever is needed. So this whole concept that we are regarding Industry 4.0 is really integral in terms of considering everything that's related to it. So when we go into the factory, we make an assessment on different scales. We have a detailed catalog that we work out, and based on this maturity levels that we see here, we make concrete proposals on how to improve the factory. We start with this internal analysis. We look at the business models, we make technology studies, and very important, we also look at the human resources and identify how to change them to allow this change. After the concept phase, we go into realization. We start with a demonstrator, make a pilot in application, and then really bring it into the serial production. And by this, we really have an approach that allows us to go forward. Yeah, I'm coming to that. Yeah. So last things. So we have some experience centers. One in Berlin, and now I'm really coming to the end. What we're building up here in Nanjing is the Sino-German Intelligent Manufacturing Research Institute, where we actually establishing a center with a demonstration center where you can really see a demo factory, demo production, training center, different levels of trainings for operational employees, management, government, and also an application center where we execute those projects that I just presented, and also a platform for incubation of startups. Well, yeah, this is it. If there's any questions, we're here based in Nanjing, also concerning the Enrich program. Also, Jesse is involved in the project and we'll be happy to give you more information on Enrich.
Thank you, Jan Patrick.